Okay, I got it. That's pretty simple only.
Yeah, go for it.
Uh, so A and D.
Hmm. See, A is correct, Lohit,
Mm-hmm.
and B is not correct.
Yes, sir.
C is not correct.
Mm.
D
And
is,
D would be correct.
D is correct.
Yes, sir.
Uh, do you want me to discuss it?
No, sir. So I think I got it. If we just equate the V is equal to root P upon U, then you can pretty much figure out everything from there.
Yeah, but there is one particular loophole here that the tension at the string is not same at each and every point.
Yes, sir. The tension in the string, it will decrease as you go towards the mass.
Tension in the it will be highest at the pulse 1 where
Yes,
pulse 1
at
is
point
generated.
A, it will be the.
Yeah,
No,
when
the tension will be highest at point O.
yeah pulse 1 where pulse 1 is generated,
Yes,
it will
sir.
be highest at that point, and pulse 2 would be minimum. And the other thing is that if tension is minimum at this particular point A, then definitely velocity will also be different. Velocity will also be less at point A comparable to point B, Lohit, comparable to
Mm.
point O. So that means that wavelength of pulse 2, right, becomes
Yes,
what?
sir.
Wavelength will kind of decrease. No? Wavelength will decrease when it reaches point A, right?
Yes, sir.
So C option is incorrect now, correct?
Mm.
And A option is correct because definitely the pulse that is going from A to O, even because of the differences in the tensions at each and every point, even if I take out an element, look at, suppose if I'm solving it in a way that, suppose if I take this particular element of this particular string, Lohit, then the velocity of pulse 2 that is going upward, let that velocity be v1, will be same with the velocity that is coming down, that is v2, because velocity is more or less related to what? Under root t by mu, correct? And here the tension will be definitely different, I'm not saying that, but tension will be same for both the velocities, like velocities v1 and v2 will be same, because here tension would be some same tension, let that tension be t naught.
Mm.
And if I take another element also somewhere here, so here tension can be, let's say it is t dash. So
Yes,
but
sir.
yes, but t dash tension is common, tension is common for the upward velocity of the pulse and the lowermost, like the velocity that is coming from pulse 1
Mm.
in the downward direction. So we can say that if velocities are same, then time interval will also be what? Time interval will also be same, correct?
Mm.
So first option is correct now. And yeah, D option is incorrect because velocity of any pulse is dependent on what? It is dependent on tension and mass per unit length. Okay, so it is independent of
Yes,
what?
sir.
Independent of frequency and wavelength, Lohit. So it is definitely correct. And I told you C option is correct because as we go from top to bottom, tension will reduce, so velocity will reduce, so wavelength will also reduce. So C option would be incorrect. Correct. And what about B option, Lohit? B option is a bit of a controversial part, but actually what answer
Hmm.
advanced have given is that B option is also incorrect, because velocities, no doubt velocities, ऊपर वाला velocity v1 है.
They'll be varying because different tension.
No, velocities will be same, Lohit. Like
हाँ.
from pulse and pulse to velocities का magnitude same है, Lohit.
Oh yes, the direction will
But
be different. So
direction is
because of that,
different.
it won't be the same.
Yeah, but direction, if we take direction, it would be different, right? So this is the case. But sometimes, some students were also seeing that they were solving using the reflection of waves concept, right? But
Hmm.
what the thing is that there was no such information given in this question regarding the reflection of waves part. So in that case also, the C option, the B option was coming out to be incorrect.
Yes, sir.
So this question is done like that. Clear? No problem till here, Lohit? Right. Okay.
Hmm.
Okay, this question is also a very good question. This is from Doppler effect, Lohit. And question is again a very good question, I would say. Why you were not able to attempt this question? Let me know. You were not able to figure out, or was it you were not getting?
So I wasn't able to figure out like how to like if I was supposed to use the relative velocity or like how to do it
Right. Okay.
because they're moving at right angles, right?
Okay. See, let me read the question. The question says a train S1 moving with a uniform velocity of 108 km per hour. So this is your S1, Lohit. Its velocity is 108, which comes out to be, I think, 30 meter per second. Okay, this information approaches a train, another train S2 standing on the platform. So this is a stationary train. This is not moving, Lohit. Okay, this is standing on the platform. And
Yes, sir.
simultaneously, what is happening? An observer. Okay, so there is an observer here on this particular line of S2, and this is moving with 36 km per hour, which is around 10 meter per second. It is moving with the velocity of 10 meter per second towards the stationary train S2, right? Both the trains are
Yes,
blowing
sir.
whistles at same frequency. So लोहित यहाँ पे जो आपकी source frequency है, that is given out how much? Both are same, that is 120 hertz. I'm writing this source frequency to be f naught, right? Source frequency is written at to be what? F naught. Okay. Okay. When
Yes,
O
sir.
is 600 meters away from S2 and distance between S2 and S1 and S2 is 800 meters. So Lohit, they are basically focused on one particular situation only. When
Hmm.
O is at a distance of 600 meters and S1 and S2 are 800 meters apart, right? Then what are the number of beats heard by O? Number of beats. So it is a mixture of Doppler effect plus beat frequency,
Hmm.
right? So this question is again a controversial question because see what is happening now. Very essentially, I will explain you. 600 meters is O situated from S2 and 800 meters is S1 from S2. At that particular instant only, they are wondering, they are asking you what will be the number of beats. So
Hmm.
Lohit, suppose that at this particular instant when S1 से जब आपका फ्रीक्वेंसी O की तरफ आएगा, है ना, जो साउंड वेव है वो O की तरफ आएगा, so definitely O will not be here at that time. Are you sure? O
Yes, sir.
will kind of, this one must have passed away. So अगर
Hmm.
इस particular situation में S1 अगर 800 meters पे अगर वो एक frequency emit करता है तो definitely it will be never be heard by O when it is at 600 meters, because it has displaced itself from this position. But since it is again a question in which you have to take that approximation, otherwise the question will be not solved. Otherwise, what you have to do? You have to do it in a way that S1 को थोड़ा सा पीछे शिफ्ट करिए, मतलब S1 यहाँ पे होगा तो O जो होगा लोहित, O यहाँ कहीं पे होगा, इधर यहाँ कहीं पे। अब जो S1 जो फ्रीक्वेंसी इमिट करेगा लोहित, अब जो फ्रीक्वेंसी इमिट करेगा, अब ये इस फ्रीक्वेंसी की बात करेंगे जब ये O पे उतने टाइम में O यहाँ पहुंचेगा, then it will be received. Actually the scenario is like this. Not getting?
Yes, sir.
Right? But you have to solve this question using approximations. Approximation here means that it is quite understood that when S1 is emitting from this particular point only, which is given in the question, जब यहाँ से emit करेगा, then O is this frequency will be heard by O, right? Okay.
Yes, sir.
Okay. So let's begin to solve this now. Okay. What I can do here is, let's mark this angle Lohit. This angle can be written as theta 1. So this angle can be written as what? This angle can be written as theta 2. Right? Okay. Now first of all you have to calculate the apparent frequencies heard by O. Apparent frequencies heard by O when it was at 36 kilometer. When it was at 600 meters, because they are asking the number of beats heard by O only Lohit. तो आप जो frequencies O heard hear करेगा from S2 and S1, that you need to calculate. So first of all, S2 is stationary, so I am saying that the frequency that is emitted from this S2, that is a source frequency of 120 Hertz, that is F0, right? It is emitting F0. But what will be heard by O, that frequency can be written as F2 Lohit. ये frequency F2 निकाल ले हम. Are you getting or not? इस F2 को निकाला जा सकता है ना. ये F2 क्या हो जाएगा? F2 will be equal to what? Formula you can tell me. Source frequency, that is how much? 120 Hertz. Then speed of sound. Formula याद है आपको Doppler effect का Lohit? That is 330 plus the velocity of observer, 10 divided by speed of sound again, and since it is stationary, so it is only 330 in the denominator. Getting Lohit this one?
Yes.
Now F2 comes out to be how much? This comes out to be 120 multiply by just try to solve 340 by 330. So we'll solve it. It will be around 334 by 30. Please check it. 33. Check it.
Yes, sir.
Right. So this is one particular case, and I'm writing this as equation number 1. I'm not solving it. Let this be equation number 1. Okay. Now let's consider the other one. Okay. Second case में, see Lohit, here was the observer and here is S1 Lohit, and it is moving in this direction like this. आप इसको इस तरह से ज्वाइन कर देते हैं, ये यहाँ पे कहीं पे इधर, and it is like this. So this angle is taken out to be theta 1, this angle is taken out to be theta 2. This distance is 600 meters and this distance is how much? 800 meters. So first of all ये distance निकालो, this comes out to be 1000 meters, right? 1000 meter का distance है. Okay. Now velocity of A along this line is what? This velocity is 10, right?
Yes, sir.
But you have to calculate the velocity heard by O from source S1. तो वो frequency तो actually जो आपकी source frequency है, that is again 120 Hertz, but apparent frequency which can be written as what? Which can be written as और F1, ये आपको calculate करना है. अब उसके लिए आपको इस लाइन के along लेना है सब कुछ, ठीक है? इस लाइन के along चलना है. तो अगर आपका 10 मीटर पर सेकेंड इसका वेलोसिटी है ऑब्जर्वर का, देन इसका कंपोनेंट इस लाइन के अलॉन्ग क्या होगा लोहित? दैट विल बी 10 cos ऑफ थीटा 2, 10 cos ऑफ थीटा 2, ठीक है? और इस ट्रायंगल से आप 10 cos थीटा 2 निकाल सकते हैं. cos थीटा 2 कितना आएगा? दैट विल बी आई थिंक 600 by 1000, दैट इज 6 by 10 लोहित. सो ये इस लाइन के अलॉन्ग जो वेलोसिटी आएगी, वेलोसिटी का कंपोनेंट आएगा रादर, that will be 6 meter per second. Am I right or wrong?
Yes, sir.
Similarly, this velocity of this S1, यहाँ पे आपका S2 है, तो ये velocity आपको निकाल के बताई है मैंने, that is around 30 meter per second लोहित. इसका component निकालिए, along this particular line, that is 30 cos theta 1, ठीक है ना? और cos theta 1 कितना आएगा लोहित? 800 by 1000, that is I think 8 by 10. It is 30 into 8 by 10 लोहित. 10 3s are 24 meter per second. ये velocity कितना आएगा? 24 meter per second. Now getting?
Yes, sir.
Now just calculate F1 very easily. F1 is which frequency? That is heard by observer from S1, right? So that will be, again formula is very much clear. 120 ब्रैकेट में बताओ, that is 330 प्लस ऑब्जर्वर का वेलोसिटी along the line कितना है? 6 है लोहित. Not getting.
Yes, sir.
Divide by 330 and minus how much? How much is the S1 का जो वेलोसिटी है ना? Remember that is 24.
Yes, sir.
Sure. This is 120 multiplied by 336 divided by 330 minus 24. I think it will be 306. लोहित, ठीक है? इसको थोड़ा सॉल्व करके करते हैं. ये 120 यहाँ पे भी लिख लो ऐसे ही, बिकॉज फर्स्ट इक्वेशन में भी है. 336 और इसको कर सकते हैं 56 से चला जाएगा आई थिंक. 56 और नीचे वाला चला जाएगा आई थिंक 51 के साथ लोहित.
Yes, sir. 51.
राइट. सो ये सेकंड इक्वेशन है. आपने F1 भी निकाल लिया. अब आपको बीट फ्रीक्वेंसी निकालनी है. तो बीट फ्रीक्वेंसी क्या होती है? दैट इज F1 minus F2 लोहित. Just solve this one and let me know the answer.